Okay, today we will discuss about exercise 9.2 FSC part 1. Here we will discuss about some important concepts like coterminal angle. First one is what is coterminal angle. So coterminal angle, if we draw an angle, this is initial side and this is terminal side of to form an angle. This is angle theta. So by name it is clear that O means same, and this is initial side of angle, and this is terminal side of an angle. Co means same, and terminal means terminal side. So angles which has same coterminal side are called coterminal angle. Like this is theta angle. So what will be the value of coterminal angle? We will draw an angle this. So first angle was theta, and our second angle which is theta plus 2 pi. So if I write my theta is 30, so what will be the coterminal angle of 30? So simply add one complete circle, one complete revolution. One complete revolution has angle 2 pi. So 30 plus 2 pi, 2 pi means 360, 360 plus 30 will be equal to 390. So these two angles have same coterminal or coterminal ray or coterminal side. So these are called coterminal angle. After coterminal angle, our second definition is about angle in standard position. Angle in standard position. So what is called angle in standard position? If we draw an angle, this is our is our initial ray, and this is our terminal ray. So angle in standard position has two properties. First one, it is along x-axis. Always it is along positive x-axis. And second property is that vertex of this is called vertex. Vertex is along origin. This is called angle in standard position. These are two properties. First one is it is always about x-axis, and second property is always vertex is origin. Similarly, this is our angle in standard position. If I draw another angle, this angle, we will take its position from positive x-axis, because this is positive x-axis. So this is our angle in standard position. Similarly, if I draw this will be angle in standard position. So this is called two properties are of angle in standard position. First one is positive. It is always from positive x-axis. This is point from positive x-axis. This is point from positive x-axis. And second is this angle is always from origin. This is origin, and coordinates of origin are 0 and 0. So this is called our angle in standard position. So after this we will discuss about what is value of sine theta if we draw sine theta. Similarly, what is value of cos theta and what is value of tan of theta. These are some important properties to uh, discuss about exercise. So inverse of sine theta is called cosec theta. Similarly, the inverse of cos theta is called secant theta, and similarly the inverse of tan theta is called cot theta. So what will be the value of sine theta, cos theta and tan theta? Similarly, inverse of sine, tan and cos theta. We will draw some diagrams to take the value of these. Similarly, if I draw a triangle which is right triangle, this is a triangle which is right triangle. So this is called x-axis, this is called y-axis, and this is the value of r. Sorry. So sine theta, this is our base, this is our perpendicular, and this is our hypotenuse. So we know that sine theta is equal to uh, perpendicular over P shows P perpendicular over H shows hypotenuse. You can also write it as perpendicular is y-axis, so hypo is r. So sine theta is equal to y over r. You can also write y is equal to r sine of theta. Similarly, cos theta will be equal to base, B shows base over hypotenuse. So value of base is equal to x, and value of hypo is r. So you can write cos theta is equal to x over r. So tan theta will be equal to, if I write here, so tan theta will be equal to perpendicular P over base B. So P is equal to y and base is equal to x-axis. So you can write tan theta is equal to y over x. So similarly, inverse of sine is cosecant theta. So you can write y over r here as r over y. Similarly, secant is inverse of cos. Cos is x over r. You can write it as r over x. Similarly, cot is equal to inverse of tan theta. So you can write it as x over y. So these are some trigonometric functions and values of these trigonometric functions. After this, we will discuss about uh, first quadrant, second quadrant, and other quadrants values. If I clear that, or if we write, this is a 2D coordinate system in which this is x-axis and this is y-axis. This is called first quadrant, this is called second quadrant, and this is called third quadrant, and this is called fourth quadrant. So what will be the method to find the value of sine, cos, tan, cosecant, secant, and cot? If we raise this is first one, this is second one, this is third one, this is fourth, this is fifth, and this is sixth. So if we draw coordinate system, this is first quadrant, this is second quadrant, this is third quadrant, and this is our fourth quadrant. So this is x-axis positive x, this is negative x-axis x dash, this is y positive x, this is y negative x. So we know about a point. Point is first value is x and second is y in two-dimensional coordinate system. So here x is positive and y is also positive. So our point will be x, y. Similarly, if we this is our point in first quadrant. If we look here, x is negative and y is positive, so our point will be equal to minus x and positive y. Similarly, here x is negative and y is also negative, so our point will be equal to minus x and minus y. Similarly, our point will be x-axis is positive and y-axis is minus negative, so we will write it as these are points in our x, y, and first quadrant, second, and third quadrant. So after this, we will discuss about uh, values of these six trigonometric ratios. In first quadrant, all six are positive. In second quadrant, sine, theta, and inverse of sine is cosecant theta. These two are positive. Other four ratios like tan, cosecant, secant will be negative. In third quadrant, tan theta and inverse of tan theta is equal to cot theta will be positive. Other four trigonometric ratios will be negative. Similarly, here cos theta and inverse of cos is secant theta. These values will be positive, all other values will be negative. And another point we should discuss here is this is 0. These are called quadrantal angle. Quadrantal angle are those angles which are or which lie on x-axis or y-axis. This is 90 degree. This is 180 degree. This is 270 degree, and this is again 360 degree. So this is our clockwise direction. So angle in anti-clockwise direction is positive. Remember, this is our clockwise direction. So angle in clockwise direction is always negative. These are some important points which were necessary to discuss before doing our exercise. So simply after these points we will do our exercise. So another important formula we should discuss here is Pythagoras theorem. So if I undo all these settings, so what is Pythagoras theorem. Let's if I draw Pythagoras theorem. So if this is our triangle with hypotenuse, with perpendicular, and with base, we can also write it as uh, R, Y, and X. So this will be equal to hypotenuse square will be equal to base square plus perpendicular square. You can also write it as R square will be equal to X square plus Y square. This is called Pythagoras theorem. So now we will go towards our exercise. This is our exercise 9.2. Question 1 is find the signs of the following. Similarly, we know that about the signs of all the trigonometric ratios. If we discuss about sine 160, this question. So we know that 160, this is our first quadrant, this is our second quadrant. So this is 0, this is 90 degree, this is 180. So if we look closely at 160, so 160 lies in second quadrant. So we know that value of sine in second quadrant is positive. So sine of this will be positive. 190. We can look at the solution of this exercise here. Simple. So sine 160, this is in second quadrant, so it's positive. Cos 190 is in third quadrant here. So cos 190 in third quadrant, cos is negative, so this will be negative. 10 115 will be negative. Secant 245 will be in fourth quadrant. 245 will be in third quadrant. So secant in third quadrant is negative. Similarly, cot 80 is in first quadrant. All the trigonometric ratios in first quadrant are positive. So cot 1 to cot 80 will be positive. Similarly, cosecant is 297. So this is our first question. Similarly, if we look at our second question, fill in the blanks. So simply sine of minus 310. Same formula which we were applying in first question we will apply here. So sine of minus 310 will be minus, this will be positive. You can remember one thing, that minus in cos and inverse of cos is secant will be positive. Simply in cos and secant, minus will be vanished or will be positive, and in other trigonometric identities or ratios, the sign will be appear in final answer. Similarly, if we write tan of minus 180, so this will be equal to minus. This was our question number 10, and this is a complete solution of question number 2. This will be minus, this will be minus, this will be positive because this is cos, this will be minus, this will be minus, and this will be positive because this is a secant. After question number 2, we will discuss about question number 3. This is an important question, so we will write it as, we had to find the quadrant of sine less than 0 and cos greater than 0. If identity is less than 0, so this will be negative, and if an identity is greater than 0, then this will be positive. So first look at sign less than 0. We can tell that sign is negative in quadrant third and quadrant fourth. This is our first answer, and cos is positive in first quadrant and in fourth quadrant. So here we will take final quadrant which is common in both. So fourth quadrant is common in both. So answer of this complete question will be our fourth quadrant. Similarly, if we look at cos less than 0 is in second and third quadrant, second and third quadrant. Similarly, tan less than 0, tan is less than 0 in second and uh, fourth quadrant. So what is common? Common is 2. So final answer of this question will be our quadrant number 2. So we will discuss about question number 4. This is simple question. If we look at question number 4 here, so what will be the value of question number 4 here? So we will discuss about trigonometric ratios and some important formulas here. So first part of question number 4 is sine. Here we will remember two things. First quadrant first, and value of x, y, and r. Find values of remaining trigonometric functions. Sine theta is given. Total trigonometric functions are 6. So we have to find the value of other 5 trigonometric functions. Sine theta is equal to 12 over 13. We know that sine is equal to sine theta is equal to y over r. So value of y will be equal to 12. Y will be equal to 12, and similarly r will be equal to 13. So simply we can find the value of x by applying Pythagoras theorem. So after applying Pythagoras theorem, value of x will be equal to plus minus 5. So because we are in first quadrant, so x in first quadrant is always positive. So we will take x as 5. So value of x is 5. So we will apply these 5 values in our question to find the final answer. Means cosecant sine is 12 over 13, so cosecant will be equal to inverse. Inverse will be 13 over 12. We know that cos theta is base over hypotenuse, so this will be equal to x over r. A value of x is equal to 5, and value of r is equal to 13. Similarly, tan theta is equal to y over x. So value of y is equal to, we know that value of y is equal to 12. So value of x is equal to 5. So inverse of cos is secant. So secant will be equal to 13 over 5. Similarly, inverse of tan is cot. Cot will be equal to 5 over 12. This is answer of our this question. Similarly, second part, cos of theta is equal to 9 over 41. We know that cos theta is equal to x over r. So value of x will be equal to 9 and value of r will be equal to 41. So we have to find the value of y. Another important thing is that the terminal arm of the angle is in fourth quadrant. We know that for in fourth quadrant, our x is positive and y is minus. So after applying Pythagoras theorem, value of y will be equal to plus minus 41 because this is in fourth quadrant. So in fourth quadrant, we know that value of y is equal to minus. So we will take y is equal to minus 40. So y is equal to minus 40. So value of x, y, and r are clear to us. So after putting the values in a trigonometric ratios, we will find the final answer. So after this, we will discuss about similarly third part of this question. Here is the solution of third part. Similarly, after this, there is fourth part of this question. There is solution of fourth part. Similarly, question of five part. If we look at the five part of this question, sine theta is minus 1 over square root 2. Sine theta is minus, and the terminal arm of the angle is not in quadrant 3. So quadrant 3 we cannot take as quadrant 3, and sine is negative. Sine is negative in quadrant 3 and quadrant 4. So we cannot take quadrant 3. So sine of theta will be in quadrant 4. So in quadrant 4, x is positive and y is always minus. So sine is equal to y over so value of y is negative. For quadrant, so y will be equal to minus 1. Uh, y is equal to minus 1, and r will be equal to square root 2. So after applying formula of Pythagoras theorem, we will find the value of x. So x value will be positive because this is in fourth quadrant. So after putting the values in trigonometric ratios, we will find the final answer. Similarly, question is 5. If chord is 15 over 8, this is question same as the previous question number 4. And the terminal arm of the angle is not in quadrant 1. The chord is positive. We know that chord is positive in quadrant 1 and quadrant 3. We cannot take quadrant 1, so final answer will be quadrant 3. So we know that tan theta is equal to y over x. So cot will be equal to cot theta will be equal to x over y. So value of x will be 15 and value of y will be 8. So after applying the Pythagoras theorem formula, we will find the value of after applying the formula, value of r will be equal to 17. So r will be always positive. So after applying the value of r, we will x, y, and r. We will find the final answer of this question. And similarly, question number 6, 7, and 8 are very important questions here to discuss about. So question number 6 is cosecant is equal to m square plus 1 over 2m. We know that cosine is sine theta is equal to y over r. So cosecant will be equal to r over cosecant will be equal to r over y. So value of r will be equal to m square plus 1. Value of y will be equal to 2m, and value of x we had to find the value of x. So simply we will apply the formula of Pythagoras theorem. So this is x square plus y square formula of Pythagoras theorem. So we have to find x. So this will be equal to r square minus y square. We will put the value of r, which is equal to n square plus 1. This is square, so this will be square. So we will open the square of this. And this is minus 2m square will be equal to 4m square. So minus 4m square and plus 2m square will be equal to minus 2m square, and this will be equal to m square minus 1 whole square. So this is in first quadrant. Meaning of this from 1 to 90 is in first quadrant. So value of x will be positive m square minus 1. We know that value of x, y, and r. So simply we will write the value of, because cos theta is equal to x over r. So value of x will be x square minus 1, value of r is equal to m square plus 1. Similarly, sec is inverse of this, and tan is equal to y over x, value of y is equal to 2, and value of x is equal to m square minus 1. So what will be the inverse of tan of theta? So after this we will find the question number 7. If tan theta is equal to 1 over square root 7, we know that tan is y over x, to value of y will be equal to 1 and value of x will be equal to x. So and the terminal arm of the angle is not in third quadrant. So find the value of because this is 10 is positive in third quadrant and first, so we cannot take third quadrant, so our quadrant will be first. So value of y will be equal to 1, value of x will be equal to square root 7. We have to find the value of this function, so this expression. So we will y is given and x is equal to given, we will find the value of r. So value of r will be equal to, after applying categorization, will be square root 8. So we will find cos is equal to cos theta is equal to x over r. So value of x is square root 7. So cos theta will be equal to square root 7 over r will be equal to square root 8. So and similarly secant will be the inverse of this will be equal to square root, secant will be inverse of cos, so this will be equal to square root 8 over square root 7. So simply we will put this value into this expression to calculate the final answer of this question. So we are putting the values in this expression. So square root 8 square minus, after cutting, this will be 8 minus 8 over 7, 8 plus 8 over 7. Final answer will be 3 over 4. Similarly, last question of this exercise is that cot theta is equal to 5 over 2. We know that cot is equal to x over y. So value of x will be 5, and the terminal arm of the angle is in first quadrant, x will be equal to 5, and y will be equal to 2. So we have to find the value of r. After applying Pythagoras theorem, we will find the value of r will be equal to square root 29. So let's find the x. We have to calculate value of this expression. We will put the value of sine. We know that sine theta is y over r. Similarly, cos theta is equal to x over r. We know that value of x is 5, value of y is equal to 2, value of r is equal to square root 29. So after putting this value, we will find sine theta and cos theta values. And after putting the values of sine and cos in this expression, our final answer after simplification will be 26 over minus 3. So this was today's lecture. So for more lecture, we will discuss in our next exercise will be 9.3. So subscribe for more, and you can say any question in your comments. The answer will be shared to you.